Hello everyone, thanks for stopping in, and today we're going to be talking about Math 100, section 5.4, and here we're going to learn how to add and subtract polynomials. Now we've already been working with polynomials, and polynomials are any equations of this form, where they have variables with exponents and coefficients out in front of those variables. So one thing we've already been working with for polynomials is combining like terms, right? So here we've got negative 3x to the 5 plus 7x to the 5. Well, they're both x to the 5 terms, and we combine them by adding the coefficients, right? Negative 3 plus 7 is 4. Similarly, these are all n cubed terms, so I can do 2 plus 5, but I need to remember that it's minus 1 here. So 2 plus 5 is 7, minus 1 is 6, n cubed. And then for the last one, I need to make sure that all of these exponents are the same. G to the 7, h to the 4, g to the 7, h to the 4, g to the 7, h to the 4. Looks good. 4 minus 9 is negative 5, plus 2 is negative 3, g to the 7, h to the 4. And we've already been doing it. That's nothing new. Same thing for this second batch of examples. We've already been evaluating polynomials. So if we have the polynomial 5h to the 4th minus 3h squared plus 4h plus 7, and we're going to plug in h equals negative 3, well, we plug in negative 3 for all the h's. And then we just follow order of operations. We evaluate exponents first. So we'll have 5. Negative 3 to the 4th tells me to multiply negative 3 by itself 4 times. Remember, with parentheses, you do repeat the negative. Negative 3 times negative 3 times negative 3 times negative 3 works out to be positive 81. Minus, and then 3. Negative 3 squared will be 9. Plus 4 minus 3 plus 7. And now we can look at the multiplications. Next we would do multiplications. 5 times 81 would be 405. 5 times 81, right? 405. Minus 27, 3 times 9. Positive 4 and negative 3, I can rewrite that as minus 12, right? And then we add 7. So 405 minus 27 minus 12 plus 7 gives me 373 as my answer. So we can evaluate polynomials, right? We've already been doing that as well. Let's take one more look at evaluating just to refresh our brains, and then we'll move on to the new topic. 5, we'll plug in a 2. And that'll be to the 4 minus 3, we plug in a 2 squared, plus 4 times 2, plus 7. Once again, we do the exponents first, right? 2 to the 4th is 2 times 2 times 2 times 2, right? That equates to be 16, minus 2 squared is 4, plus 4 times 2 plus 7. Next, we move on to the multiplications. We get 80 minus, we get 12 plus 8 plus 7. So when I do 80 minus 12 plus 8 plus 7, works out to be 83. We get 83 when we evaluate this polynomial at h equals 2. So notice you can plug in polynomials. We've already been doing that, right? The new thing we want to do is adding polynomials. To add two polynomials, we combine like terms. We add the like terms. That's all we got to do. Combining like terms is adding polynomials. So let's take a gander here. We have 8y cubed minus 7y squared minus y plus 3, and we want to add 6y cubed plus 2y squared minus 4y and plus 1. Now, sometimes we might pair up the like terms vertically. And then y squared would be next, and this is positive 2y squared, and then the y terms would be next. This y here is minus 1y, this one is minus 4y, and then we have plus 3 and plus 1, right? I wrote each polynomial vertically over top of each other, right? 8y cubed minus 7y squared minus 1y plus 3, 6y cubed plus 2y squared minus 4y plus 1. And then I just add to get my answer. 8 and 6 make 14y cubed. Negative 7 and 2 make negative 5y squared. Minus 1 and minus 4 make minus 5y. Plus 3 and plus 1 make plus 4 when you add. So we just add vertically. Now, in my second example, I'm going to try the same thing, but I need to be careful. There's no n squared, right? So I'm going to write my 2n a little distant, and then here I have 1n squared minus 9n and plus 12. Notice I'm lining the like terms up. There was no n squared in the first polynomial, just like there was no constant in the first polynomial, right? And then there's no n cubed in the second. So, when I go to add, I'll get 7n cubed plus 1n squared is just n squared. Positive 2 and minus 9 make minus 7 when you add them together. And then plus 12 will be floating along for the ride. Now, we don't always have to add vertically. Sometimes you can just write out both of your polynomials. And I like to put them in parentheses and put a plus sign in between them. And then I walk through exponent by exponent. I do my n to the fourths first. 2n to the fourth and negative 5n to the fourth add to be negative 3n to the 4. Next, I check out the n to the thirds. I've got 1 here and 1 here. Well, I'll have negative 7 and negative 8. Those add to be minus 15 n cubed. Next, I would look for n squareds. There are none. I would also look for n's. There are none. There are no n squared or n terms. So I move on to the constants. Negative 4 and positive 10 combine to be plus 6. So I get negative 3n to the fourth minus 15n cubed plus 6. And then same thing for my last example. If I have to add 7p cubed minus 9p minus 4 and 5p minus 1, well, I only have like terms on the p's and the constants. So I already know the 7p cubed will be left alone. Negative 9 and positive 5 add to negative 4, and that has a p on it. And then negative 1 and negative 4, those add to be negative 5. So there's a few different techniques for combining the like terms. Feel free to use the one you're most comfortable with, whether it's vertical or horizontal, totally up to you. Now, we just saw how to add polynomials. It's kind of new, but it's not really, right? We've already been combining like terms. We're just now having a specific focus for our combining like terms. We can also subtract polynomials, and let's look at what it says here. It says to subtract two polynomials, change all the signs of the second polynomial and add the result to the minuend. Remember, the minuend is the first polynomial. So I change all the signs of the second polynomial and add the result to the first polynomial. So let's take a look at some examples of subtraction. Here we have 3x minus 5 minus 6x minus 4. And so what I do is I rewrite this problem. I write the first one exactly the same. I turn the symbol in between to addition because I'm going to distribute this negative through the second polynomial. it will change both signs, right? A negative will change a positive 6 to a negative 6, and a negative will change a negative 4 to a positive 4. Now, this problem is now addition. That's what we just did on the previous page. I have turned my subtraction into addition. 3 plus negative 6 is negative 3x, and negative 5 plus 4 is negative 1. Now I need to be careful in the second one because I want to subtract y cubed plus 4y squared minus 2 from 7y cubed. So I'm going to write 7y cubed plus 8, and from it I am going to subtract y cubed. I can put a 1 there if I want, right? There's a hidden 1. Plus 4y squared minus 2. And once again, we're going to keep the first polynomial the same. We're going to change to addition and distribute our negative. The 1 will become negative 1y cubed minus 4y squared plus 2. Right? Distributing the negative changes all these signs. And now we're back in addition. Let's see, like terms. We've got y cubes. Let's see, 7y cubed plus negative 1y cubed would be 6y cubed. Next, I've got y squareds. There's no like terms with it, so I'll just leave it as minus 4y squared. There's no y terms, so I'll move on to my constants. I have 8 and 2, which will be plus 10. So with subtraction, we can turn it into addition. Now, we can also do it by subtracting by columns. We can line things up like we would. 4g to the 4 plus 6g cubed. I'm going to skip a space because there's no g squared. I'll put minus g. I'm going to put a little 1 with it. And minus 5. Now, I need to be careful because when we work vertically, we want to make it addition, right? So when I copy these down, I'm going to change each of their signs, right? Because the negative is being distributed through. So I'll have positive 6g to the 4 minus 2g cubed. This also has no g squared, so I skip it. But it's plus 4g and minus 3, right? I need to change all the signs. So I can subtract by columns by setting up a vertical addition also. You can do both problems vertically. Just be careful with your signs. Adding vertically gives me 10 g to the 4. 6 and negative 2 add up to be positive 4g cubed. Negative 1 and positive 4 make positive 3g. And minus 5 and minus 3 make minus 8 when I add together. So we can work vertically for subtraction just like we did for addition. Now, what if we have to do multiple operations? We want to subtract then add. Well, first I'm going to turn this subtraction into addition. So I'll copy down this polynomial. This symbol will become addition, and I need to flip all the signs in this polynomial, right? I'm distributing this negative sign. It'll be minus 6, minus 4m, and plus 7m squared once I distribute the negative, right? And then the last one is addition, so I'll leave it alone. 9 minus, maybe I'll put a hidden 1 in front of that m just so I remember it's there, plus 3m squared. Now, like terms, I need to combine them. 2, negative 6, positive 9. Well, combining those like terms, 2 and negative 6 make negative 4, and then plus 9 would be positive 5. Next, I'll move on to the m's. Minus 3m, minus 4m, and minus 1m. All of those are negative, so negative 3 and negative 4 make negative 7. Take one more away, will be negative 8m. And then, lastly, we can look at the m squareds. They're all positive, so when I add them, 5 and 7 make 12, and 3 more is 15, so plus 15m squared. So we can perform multiple operations by making sure we're only combining the like terms. Now, on the last page, we've got an example of addition. Look here, be careful with the terms. We've got C terms. 6C plus 3C would be 9C. Next, I have CD terms. Negative 2 and plus 9 would be plus 7, right? CD. And then lastly, I have D terms. 1D, right? There's a hidden 1 if we want. And negative 4D, those add up. 1 and negative 4 add to negative 3D. So I can work with multiple variables in my same polynomials. And let's look at the next one. Let's first work with the subtraction. Well, I'll keep the first polynomial the same. And for the second one, I distribute the negative, right? It'll be negative 5a squared b plus 3ab minus 7b squared, right? I'll switch all the signs because I distribute that negative. Now, for like terms, a squared b, a squared b. All right, cool. These are like terms. 2 and negative 5 add up to negative 3. And that was a squared b. Let's look next. AB. I've got AB terms in both. AB and AB. Negative 4 and positive 3 add up to negative 1. You don't need to write the hidden 1, though. And then lastly would be b squared and b squared. B squared minus 7b squared is negative 6b squared. So this would be my final answer once I have combined my like terms for this set of polynomials. And that brings us to the end of section 5.4. I thank you for stopping in, and I will see you next time.